Welcome back to Easily Explained, where today we will be talking about limits to growth. So let's get started. So today we're going to be talking about factors that limit a population's growth. These are called limiting factors. They basically cause the population to decrease. And today we are going to be talking about the two categories of limiting factors. Those two categories are density-dependent limiting factors and density-independent limiting factors. So they both are limiting factors. They both cause the population to decrease in size, but one is dependent on density, the other is independent on density. So let's go over both of them in more detail and some examples of density-dependent and density-independent limiting factors. First, let's talk about density-dependent factors. Density-dependent factors affect populations differently based on each population's size and its density. If you recall, when we talked about characteristics of growth, one of the characteristics we talked about was population density. And we taught that the density is the number of individuals per unit area. So basically, it's how crowded a species is and how many individuals that live in that area. So when we talk about density-dependent factors, these factors depend on the size of the population, and so they operate the most strongly when the population is large and dense. So populations that have larger population densities are much more likely to be affected by these density-dependent factors. Whereas when we talk about small populations or scattered populations, they are not as greatly affected by these specific factors. Now let's go over some examples of density-dependent factors. Competition is a density-dependent factor because when we talk about large, dense populations, they're going to need a lot more resources, and those resources are going to run out much sooner. And then this will lead to competition for resources like food, water, space, sunlight, and these are all necessary for the population or the individual's survival. Competitions can occur between members of different species, which would lead to evolutionary change, or it can even happen in the same species. And then that's where we start to see population decreasing. Another example of a density-dependent factor is predation. Going back to the first bullet point over here under competition, the more organisms in a population, the more resources they're going to need to survive, for all of them to survive. That means they need more food. And when we talk about predation, the growth of the predator species or the survival of the predator species relies on the prey. So that means that if the prey itself is not very available, it's pretty rare, that means the predator population is going to be severely limited by that. Whereas if we talked about a animal that lived its life in solitude, a solitary animal, or some small scattered populations, they would have a lot more chance of survival in that case if the prey itself is limited, because they only have to fend for themselves. And there are less people or less animals to feed, and so they wouldn't be as affected by the availability of the prey. Yes, they would be in a way because they are also less likely to get food. But when we talk about density-dependent factors, we still consider predation as a density-dependent factor because it influences larger populations much more. It affects them much more than it does the smaller ones. And the last factor that we're going to talk about, the last example of the density-dependent factor, is parasitism and disease. So these ones are obvious as they spread quicker through denser populations. So especially when we talk about diseases that spread through contact or parasites that spread through contact, the more contact an animal has with its species, the more likely it is to pass that disease down to others. And so when we talk about smaller scattered populations, they're less likely to catch disease themselves, first of all, because they're in solitude and they don't have much interactions with other animals. But if they were to get a disease or parasite, they would have less chance of spreading it to somebody else, and that disease might just die with them, or the parasite might die with them. And so that's why when we talk about density-dependent factors, they usually only really affect larger, more dense populations. Congratulations, you're now an expert at density-dependent factors. If this video helped, please like, subscribe, and share with your friends, and we'll see you guys next time to talk about density-independent factors. Bye!